Welcome back, everyone. So there is three hard things in computer science. One is casting validation, two is naming, and five is estimating how long it takes to build something. But it's a good thing then that we have Maurice de Beijer with us today, who is a independent software consultant and a trainer. Maurice is a certified great guy, is involved in open source, teaches courses on a plethora of subjects, is a Microsoft MVP, and helps organize the Dutch.net user group. So whenever you're ready, Maurice, please tell us how to make better estimates.
Thank you, and I'd love to. So, welcome everyone. Good afternoon, and welcome to this session on a foolproof way to make better estimates for software projects. At least it's for me a pretty much foolproof way, but I hope you can pick up a lot of tips from this and use them yourself. And it helps if the right window is focused. So who am I? My name is Maurice de Beijer. I'm Microsoft MVP, developer, instructor. I typically work a lot with startups and help them get things done. So what am I going to talk about? Well, first we're going to talk briefly about no estimates, which is kind of a buzzword sometimes on Twitter and hashtag no estimates, and why you might want to do that or probably won't. And then I'm going to look at two ways of estimating software, or at least two techniques I use a lot. The program evaluation review technique, or PERT, and part of that, the most important part, I think, 3-point estimates. And then we're going to take a look at how OpenAI and ChatGPT can help us use those two techniques. And finally, it's not so much about estimation, but if I've got time left, I've got a few things to say about team size and how you should work with teams over the lifetime of a project. But first, no estimates. I'm sure you've seen the hashtag on Twitter or somewhere else where people say, well, all estimates are wrong anyway, so why bother with estimates? If you can't do a proper estimate, it's just fake and it doesn't really help anything. Well, that might be true, and there is certainly a lot to be said for it. But in reality, most software projects are business related. If I do my own personal project, like I recently redid my own personal website, I'm not going to bother with estimates. I'm just going to start with it and do it. But when I work for clients, it's business related. There is money involved, there are deadlines, and it's kind of like you have to do something, you get started, and well, we're finished when we're finished. It might take 2 weeks, it might take 2 years, which is a really rough estimate, but still, I guess, an estimate. That doesn't really fly. Even if you're doing a really simple application, like suppose you're building an app to send out Christmas cards, like if you don't do an estimate and it's done the week after Christmas, it's pointless. There is this deadline for Christmas. There is typically money involved, like a budget. Like a company wants to make money. They estimate that if they build a certain package, they can make, say, 1 million a year. But if building that software costs 100 million, I'm exaggerating numbers a bit here, of course, but if it costs 100 million, then it's pointless. It doesn't make sense. It's much wiser just to put the money in the bank, get interest in that, and you'll make more money. So no estimates most of the time. It doesn't work. But, well, the no estimate movement comes out of the fact that software is hard and there are a lot of uncertainties there. So, how can we start estimating? Well, we can look at history. And there's been lots and lots of projects in the past, not just in software, but in very different industries, which were hard to predict. They were complex. And I've got some examples here. And one is building nuclear submarines. This is actually a picture of a relatively recent one. But what I'm looking for is how they built the first Nautilus nuclear submarine. The US Navy did that. It was kind of like the time where nuclear reactors existed, but they were huge buildings. Submarines existed, but they couldn't stay underwater for very long. They were basically electric and diesel engined, so they had to surface, get air. And putting a huge building inside one of those relatively small submarines was quite impossible. Yet they wanted to do that and they had to start planning around it. There are similar projects. Like in September 1962, President Kennedy said we'll put a man on the moon by the end of the decade. And that was extremely ambitious. Like the US had put rockets into space. That wasn't exactly new. They had put people into space, a few at least. That landed on other planets, and or maybe not planets, but on the moon. But those landings were more of, well, semi-controlled crashes. Putting a man on the moon, landing there safely, putting him back up in space, flying back to Earth, landing him back safely on Earth was kind of like, how are we going to do that? We've got no clue. Yet they did it. Before the end of the decade, in July 69, Neil Armstrong and Buzz Aldrin walked on the moon, planted the American flag there. Now, how did the US Navy and NASA pull off complex projects like that? They just didn't start and, well, let's hope for the best or could plan everything out, because there was lots and lots of uncertainty there. There are lots of technology that had to be developed, both for the nuclear submarines and for going to the moon. Lots of things just were completely unknowns. So they used a technique called the Program Evaluation and Review Technique, or PERT for short. And PERT is basically a method for analyzing work and completing a project where you know relatively little about the project. Like, you know it's complex, you know there is a lot to do, a lot of tasks which need to be done. You know you've got some kind of deadline when it needs to be done, but you kind of have to figure out, is this even possible? Can we even achieve it? And using PERT, you can kind of start making sense of all those uncertainties and start building out a project based on that. Now, if I looked at the average software project, it's maybe not quite as complex as this, but it certainly feels similar. We're starting off with a project, and there will be some kind of brief, like what are we going to build? But exactly what we're going to build, well, we typically don't know. How many people are involved? Where are we going to interrupt with? What systems? Lots of uncertainties. And people might say, oh, we're going to interrupt with this bookkeeping application, for instance. Shouldn't be too hard. We can probably do that in, say, a week. But that's all based on guesses, and they might have done it before, but in most cases, they might at best have done something similar or probably not even at all. And a brief might look pretty simple. I've got an example here of a CRM application. So product requirement documents. And this is typically something which you find at the beginning of the project. And there is some introduction, just a paragraph of what it should do. There are a bunch of features it should have, like it should be secure. We're going to use OAuth because the company is using that in other places. It should do some customer tracking, some sales analysis. There is something about credit ratings for customers, something about the technology. But at best, there is a paragraph there. In most cases, there is just a single line there. Typical stuff you start with a project. How we're going to turn that into an actionable list of tasks and evaluate those tasks, well, that's where PERT comes in. Now, PERT is actually pretty complex and there is a lot to it. But I think one of the most important things is 3-point estimation. And why is 3-point estimation so important? Well, in many cases, estimations are based on very limited information. So people kind of know very little, just something like that requirement document, which I just showed. and they start estimating tasks, estimating how much work each task is. And you're not going to find everything in there. There are going to be lots of uncertainties. But typically, when people estimate, they come up with a number. Say a given task is going to take 3 days, for instance, or maybe 3 weeks or 3 months, doesn't really matter. And they'll kind of assume that it looks like this. So I've got a task here and I'm estimating it to take 3 days. And I realize my estimate is not exact. So it might be a bit shorter, it might be a bit longer, but I'm kind of guessing, well, it could be 2 days shorter. Like if I'm really lucky and all the stars align and everything goes according to plan, or I might have some setbacks, then it will be a bit longer. So I'll take a bit of a margin either way, but on average, that's going to be 3 days. Well, there is something wrong with this assumption. You might think, well, it's probably going to take 3 days, but are you really likely to do it 2 days faster if all the stars align and 2 days slower if everything goes against you? No. The chances of everything going against you and it taking much longer are a lot bigger. So the graph should look much more like this. So we're still thinking, well, it's probably going to take 3 days. And if all the stars align and everything goes perfectly smooth, we'll do it in 1 day. But if we'll have setbacks and things don't work out quite the way we want, it might take as many as 9 days. Now, the 3 points estimate uses this. So it basically says we've got 3 estimations. One, which is the most likely case, 3 days. One, which is the optimistic case, 1 day. And one, which is the pessimistic case, in this case, 9 days. And we'll combine those and we'll calculate a most likely time for this task. And if we do this for a lot of tasks, then we can actually get much closer to a realistic estimation. So the formula we use is actually pretty simple. So the time estimate is the optimistic plus 4 times the average we estimate plus the pessimistic divided by 6. Which kind of shows that if we use that first curve where I said 3 plus or minus 2, it's like it's 1 plus 4 times 3 plus 5 divided by 6 is exactly 3. So our estimate is, or the time estimate is no better than the original rough estimate of 3. But if we say 1 plus 3 times 4 plus 9, we end up with, I forgot from the top of my head, but quite a bit longer. Now, if you look up 3 points estimate on Wikipedia, you see this chart or this graph, well, table. I copied it from there, and you kind of get these numbers. So we've got an average here of 5. So the normal time it should take is 5. If everything aligns, we'll be able to do it in 3 days. And if we're really pessimistic and everything works against us, we do it in 9 days. Now, the first line actually has 2, 4, 6. So the gap on both sides are the same. I never do this because you just end up with your normal standard evaluation. My rule of the thumb is the gap between pessimistic and normal should be at least twice optimistic and normal. So if it's optimistic 2 and the norm is 4, then pessimistic is going to be at least 8. And quite possibly longer, because if I set it to 8, it means, well, there isn't all that much uncertainty. I'm pretty sure about this. So we're pretty sure about where we're going to end up. In many cases, you won't be quite as sure. So I might have something like, well, the norm will be 4, optimistic will be 2, and pessimistic might be 10 days or even 20 days. So the actual expected time becomes longer and the spread between the most optimistic throughput and the most pessimistic becomes longer. So based on that, we can create a Gantt chart, and that will kind of tell us when we're complete. So we kind of put all the tasks in there, check which task depends on what, how much we can do in parallel with different developers, different teams working on things, and we kind of have an average. Now, over here, there is still a single point. Um, I don't give a customer a single point. I give them a time range based on optimistic to pessimistic, because it's not like we're going to do those 3-point estimates and then end up with a single number. It's going to be a range where, say, the most likely is 20 days, optimistic is 15 days, pessimistic is 30 days. So I'll say, well, we'll probably be done in somewhere between 17 and 25 days or so. I make it a bit smaller than the optimistic and the pessimistic, but it's going to be a range like that. Because in reality, you don't know exactly. It's always kind of like in that area. There's almost certainly going to be setbacks. There will be some optimism, like you'll get lucky, but you can't predict exactly when you're done. Now, predicting tasks is one thing, but we kind of have to know what activities we have to do in order to start estimating them. Because if we've only got this PRD, the product requirements document, and it just has some, well, one-liners in there or short paragraphs, it's like, what tasks do we actually have to perform in order to get this whole project done? And that's typically very hard. And there is a reason for that. There is this law from Miller. It's a well-known law in psychology. And he says, well, there is this magic number of 7, and take plus or minus 2 there. And that's the capacity which our brain can work at, which basically means that your short-term memory can hold 7 or thereabouts items. So if you're looking at the PRD, like I just showed you, and you're going through that, you'll be able to pick up on a bunch of items in there, but you won't pick up on all the nuances and take all of that into account when doing estimation. Your brain just doesn't have the capability to do it. Now, he says the magical number is 7 plus or minus 2. In general, people in IT are relatively smart and analytical. So I'm tempted to say, well, we're probably on the +2 side. So we're probably able to work with 8 or 9 items in short-term memory and evaluate those. But that's still way too few to work with a large application and do a proper planning and keep all those details in mind. But we're not the only ones with that problem. So if you just start memorizing things and reading through it and analyzing it, it's kind of a game of cards. You kind of turn cards and you might be lucky and you might turn up the right card, but it's just chance. But is there something we can add from the future, some new stuff which will help there? And it's kind of like we've had those Google glasses. Could you create some kind of Google glass where you can look through when you read that PRD document, and it actually helps you come up with all those tasks which need to be performed? So it's not just your brain capacity, but you're actually using the power of computers, internet, and all the other knowledge out there. Well, it turns out we've been doing that. Cancer prediction has been done by computers and more specifically AI technology for quite some time. Now, AI is in many forms of cancer better at detecting cancer than the actual medical specialists. Why is that? Well, just like with other things, humans can do those 7 plus or minus 2 items in short-term memory and use those to evaluate something. Lots of forms of cancer take like 20, 25 indicators to evaluate what the risk is of someone having cancer. And medical specialists, they're smart, so they're probably on the +2 side as well. They can look at, say, 9 of those indicators, but they can't evaluate all those 25 indicators. But AI doesn't actually have that problem. AI is perfectly happy at looking at many more indicators and taking all of those into consideration when predicting the likelihood that someone has cancer. And as a result, properly trained AI is much better at generating a likelihood of whether someone has cancer based on diagnosis than a medical specialist. And it turns out nowadays we can do exactly the same with that PRD. We can go to OpenAI, ChatGPT, which is really good at processing text, lots of language models there, and it can analyze it. It can take information from the internet. It basically is trained on a lot of data from the internet, so it has a lot of knowledge. It knows a lot about software development as a result. It knows a lot about project management as a result. So we can give it our document, our PRD, saying, well, this is what we want to do. Give me a list of tasks. And that's exactly what I'm doing. And that's not hypothetical. Just 2 weeks ago, I did exactly this. A client asked me about a project they wanted to do. Like, we've got a web app, but we want a mobile application, and it should have a subset of all the web capabilities, but those are still in development as well, and they don't know exactly what. So I went through exactly these steps to make a prediction there. I don't know if the prediction is going to be accurate yet, because we haven't actually done the project yet, but it's turned out pretty well for me with other projects in the past, even before I could use ChatGPT. So here I've got ChatGPT, and this is a little video because ChatGPT is not really deterministic. So if I actually try to do this online, it would probably do something slightly different. Here on the right, you can see some settings. I set the temperature to 0. That's to make it more predictive. Normally that's set to 0.7. Basically, if you put it to a lower temperature, it becomes more predictive and less, well, flaky. So play around with those values for you. Also set the maximum length to a bit more, otherwise it will just stop generating output. So I basically gave it a prompt from generate a list of tasks based on this PRD with a bit more information. And then I just pasted in that whole PRD, which I just showed you. Click submit, and ChatGPT basically starts running there. So based on the providing PRD, it comes up with a whole set of tasks. Now, it doesn't really do it all that fast. Like, this is real time, just as fast as it types it. So a fast typist could probably type faster than this. But it does come up with a whole set of tasks. We need to do a product setup. We need to do backend development. There was something in the PRD about using React on the front end and Node on the back end. So it knows about that. There was something about using OAuth and Auth0. So it includes tasks for that. It includes tasks for testing, for maintenance, and security, compliance, and lots of other stuff. Oh, and deployment as well, of course. So it comes up with a pretty decent set of tasks. It's a bit waterfall-y for my taste, but I never told it to not use waterfall and be really agile. You kind of have to be very explicit about those things, otherwise ChatGPT will just do whatever it thinks best. But you can tweak it quite a lot. So I'm not going to wait for this to complete. If you want to see the complete output, you can download the slides from SlideShare or watch them on SlideShare and get them from there. And by now it's actually done. Now, how do I create a prompt? And I didn't want to start it again. Because with ChatGPT, crafting prompts is really the difficult thing. That original prompt really determines what you get out of it. And changing it slightly will greatly change the outputs. Just adding a few sentences will change it, but even reordering the same sentences will affect ChatGPT. If you move something up higher, it's going to assume it's more important. At least that's my understanding from its behavior. And it will come up with different things. Well, there is this whole thing about prompt engineering these days. And that's kind of hard, but how do you get a good ChatGPT prompt? Who knows all about ChatGPT? Well, ChatGPT itself. So I've got this meta prompt, the top one, which kind of starts like, I want you to be my prompt creator. Your goal is to help me craft the best possible prompt, etc. And probably the most important part is this. Based on my input, you'll generate 3 sections. A revised prompt, suggestions about things I should add or not add, and ask questions about what my intention are. So if I scroll down a bit, you can see ChatGPT comes up with, well, what should be the prompt be about, because it doesn't know anything about what we want yet. So I tell it, I want you to provide, I will provide you with a PRD, generate the tasks, etc. Then it comes up with a revised prompt. So that's kind of the prompt to use. And then it comes up with suggestions to consider and additional questions. And you go through this cycle where you answer the questions, you tell it to include some things from the suggestions, and it will update the prompts, come with new suggestions until you're happy with the prompt. If you want to get started with this, download the slides. In the notes section of these slides, you'll find this meta prompt. So that way you don't have to type it in, you can just copy it from there. But that's what I basically did to create that first prompt and all the other ones as well. Although in some cases, I didn't really go through the cycle of answering a lot of questions. I just kept it relatively simple. But based on that list of tasks it generated, we can start using estimates using PERT and 3-point estimation. So again, I'm going to ask ChatGPT from give me time estimates using 3-point estimation. And I included things like, well, I want to put this into an Excel formula so I can actually start working with it. Why do I do that? Well, ChatGPT is not very good at math. It can add numbers together, but if you ask it to add 2 plus 3 together, it will probably say 5. But if you say that should be 6, it will say, yes, you're correct. 2 plus 3 is 6. So in general, I don't like to let it do math. You can prompt it in certain ways where it will be more accurate, but there are much better tools for that. But it comes up with a list of tasks. It comes up with 3-point estimations, like the project setup is 2 days, optimistic 1, pessimistic 4, and things like that. And I can paste those into Excel. And I've got an Excel spreadsheet right here, which contains just that data. And then I can start tweaking it, say, well, that API endpoint is, well, I'm not so sure about that. That should probably be a bit more uncertain. So I'll change pessimistic from 20 to 30 days. And I might say, well, testing, well, we're pretty good at that. So I'll make that 14 to 20, for instance. And I'll kind of tweak this and probably I maybe add some more tasks, which I think should be in there, but ChatGPT never came up. But kind of based on these numbers, I will continue. ChatGPT, if you let it do the addition, you'll end up with something like this. So it says here, optimistic 2, most likely 4, pessimistic 6. And as we've seen before, 2 plus 4 times 4 plus 6 divided by 6 is going to be 4 and not 4.3 where ChatGPT came up with. So be careful with the values it comes up with. Now, in general, you want to create this into a Gantt chart to make it a bit more visible. And there is this really nice tool, online tool, Mermaid, where you can paste in text to create diagrams. And one of the diagrams it can create is a Gantt chart. So a project set up with tasks starting after each other. So I've got another task here after A1, and a task, the first one, is labeled as A1, so it automatically knows that it's going to go after there. So if I change this to say 40 days, you could see that the tasks here changed and another task automatically expanded, which is really nice. And you can have things after multiple times. So I could say this task is also after A1 and after, say, this one isn't labeled, but let's label that B1. So I could say this is after A1 and after B1. So you can see that that task moves all the way over there. Well, it turns out that ChatGPT actually understands that mermaid syntax for charts. So I can ask ChatGPT, okay, give me a Gantt chart based in mermaid syntax. And I added some additional things when it's the start date of the project, exclude weekends, create separate tracks for front end and back end, etc. So it will actually create different Gantt chart sections, give it a nice title, and things like that. So ChatGPT is going to generate that. I'm not going to wait till the end, but it basically ends up with this. And I can kind of take that, paste all of this inside Mermaid, and we'll get a nice chart there. So opening up Mermaid, just pasting that whole Gantt chart source in there, and I've got a nice chart. Now, one thing that's really nice about Gantt charts, or mermaid charts, I should say, if I take this, let's just take that one, and I go to GitHub or many other things, if I have some markdown here, I can actually just paste this in. And by default, it won't understand it. But if I use triple backticks to tell it this is code and it's actually mermaid syntax, GitHub understands this and it will actually draw that Gantt chart here on the fly. And lots of other systems will understand this too. Like if you're using Jira, Jira can do this. Jira needs a plugin, so it is a bit more work, but once you've got that plugin installed, it will do exactly the same thing. But in GitHub, really nice, it's completely out of the box. And anytime you make a change here, like let's remove this again. So it's automatically after the task in sec. So it's automatically updated, except it's gone now. So I guess I made some typo there. But really nice to make that visible that way. Let me find my slides again. There's the Gantt chart. Actually, I wanted to go to the next page where I've got the Gantt chart. So almost done. Just want to spend a few more words on team size, because the size of your team and probably more important, the members of your team at the different stages of the project is very important, and it's something which I often see go wrong. And there is this law, Brooks Law, which has been around for ages, and he's got some famous quotes about projects, like one woman can make a baby in 9 months, but nine women can't make a baby in 1 month. It's not a matter of just paralyzing it. Some things just can't be paralyzed and have to be done one after the other. Another important quote from him: adding manpower to a software project that is behind schedule delays it even longer. Like you might say, well, we're running into issues, we're almost done, but it's kind of this last push. Let's add a few more developers to it to get it done. It won't make your project done any sooner. Those people have to learn. There is more communication going on, so it actually slows down the project. So my general rule when running a project is start with a small and experienced team. They're going to make the choices of technology, architecture, and they're going to set things up. And then once that's set up and everything is running, you can add more developers. I actually said less experienced developers, but of course they don't need to be less experienced. But you can just add more developers and get a lot more work done. The number you can add really depends on how many things you can parallelize. Um, if you're just waiting on each other, then you have too many people in there. And then in the end, when you're nearly done with the project, quite often you find that projects are struggling a bit, like there are bugs that need to be fixed, and you kind of run into situations where you fix one bug and that actually introduces a new bug. Well, that's the point where you shouldn't add more developers. Instead, you should remove developers. And I said, make a note here, remove less capable developers. And less capable does not mean less experienced. It doesn't mean go back to that original team. It just means evaluate which developers are really good at having a good mental model of the whole application. Some developers have a knack for making changes and understanding the impact of their change. Like, I'm going to make this little CSS change here, but I know it's going to affect this other thing. And other developers have that much or a much smaller understanding there, fewer capabilities there. Well, you want the developers who are very strong in that regard. And that could be junior developers. They could be junior developers who just have a good memory and a good overview of things. It's by no means the experienced developers, but choose based on having that capability. The better they are at overseeing the result of changes, the consequences of changes, the more likely you'll be done faster. And the fewer developers you have, less communication, more focus, and you'll actually get done a lot faster than by adding people or keeping the team the same size right up until the end. Of course, hopefully you're not struggling at the end and everything is smooth, but I do find that a lot of projects are. So conclusion, no estimates. In most cases, at least in my opinion, it doesn't work. Like the small hobby application, yeah, sure, don't really need to estimate that. But any business application, there are deadlines, there are budgets, and the business will want to know when it's done, how much it's roughly going to cost. Lots of times you'll have uncertainties. Use the project evaluation and review technique, and especially the 3 points estimates, to help you out with those uncertainties and give you better estimates. Use ChatGPT or similar capabilities to find tasks, estimate tasks, suggest additional tasks you might never have thought of, like just setting up a database. We also have to do that. Well, ChatGPT will come up with suggestions like that, where you might just forget a small but vitally important detail like that. And keep your team size small, especially at the end of a difficult project. With that, I'd like to thank you for attending this. I hope it was useful. And if you have any questions, I'd be happy to take them now. My slides are on SlideShare. You can download them from there. I will also tweet them out, so my Twitter handle is there. I'll tweet a link to them so you can find them that way. Or just go to my website and there is a link there to all my slides.
Awesome. Thank you, Maurice, for a wonderful talk. So keep an eye out on Maurice's Twitter if you want to get those slides, or go to his website. While we wait for questions to come in, if there are any, I wonder if ChatGPT can factor in my ADHD and help me with my estimates, because I find it a lot harder to do estimates because of it. But anyway, it's more of a side note.
Yeah, for me, it really helps. Because it's so hard to keep everything in memory when you're evaluating documents. For me, just having ChatGPT do that for me helps. But it is a time sink because there's always more details it can give you. So if you just keep asking it questions, it will keep on producing more text, and more is not necessarily better.
Yeah, excellent. We do have a question, or actually a question in 3 parts. So let's start. Do you have examples of actual projects done for which you used estimates done with the help of ChatGPT?
ChatGPT, no, not yet, because that's relatively new. So like I mentioned, I just estimated a project 2 weeks ago, and we still actually have to start that. So my estimation was, if on the top of my head, I think it was like between 3 and 4 months, in that time range. So by the end of the year, I should know how accurate that's going to be. Before,
Awesome. Yeah.
Oh, yeah, sure.
Yeah, no, I meant for next year Dev Days, you can give an update, right?
Yes, I'd love to.
That's already booked you. Yeah, because then a follow-up question would have been, can you compare estimates that you used with or that you got with other tools, if you can benchmark that against ChatGPT? But maybe
No,
only for hobby
not
projects,
yet.
but not necessarily for real-life projects. Okay.
Yeah.
So you owe us an update talk.
I'll be happy to do it.
Perfect. I'm curious, what are your own multitasking skills like, if you have any?
I'm just as bad as other people, except maybe I'm slightly better at realizing I'm bad at it. In my opinion, everyone who thinks he's good at multitasking is just fooling himself.
Yeah.
Humans are basically not very good at that.
No, are definitely incapable. All right. Well, I don't see any more questions, but please join us in the chat on the Pine platform after, and then we can talk further there. Thank you so much for your talk, Maurice, and have a great day.
You're welcome. Thank you. Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship ever stars. We don't need